mute myself.
So this is Crossing the Chasm, a Webapp pen testing story. This was originally presented at DEF CON 30, and we are bringing it to you live remotely. So next slide, I guess. Thank you. So my name is Sam, aka Irby Sam. I'm a hacker. I'm a security engineer by day, hacker by night. And I like to think I'm working to make the internet a slightly safer place. I have a couple of black badges from DEF CON where I got lucky enough to stumble onto an awesome team, and we won a couple of contests. And far more importantly, I got a puppy earlier this year, and that's a picture of her, and she'll be making an appearance later in the slide deck.
All right. And I'm Justin Gardner. I just moved that to my other monitor window. I'm a full-time bug bounty hunter, and I think your statistics might be a little bit outdated, Ryan, but I definitely have been doing a lot of bug bounty this year, just competing in a lot of bug bounty competitions and stuff like that. So I do that full time. So that's been a blast. Had the opportunity to do that full time for 2 years, and travel to Japan, lived over there for 2 years, and just moved back to Richmond, Virginia, where I currently live. And I'm currently spending a decent chunk of my time teaching new hackers, just some of my friends and acquaintances that I know that are interested in the hacking space, getting them into bug bounties. If you've heard of me before, it's likely because of my Grafana CVE that kind of broke a lot of things in 2020. My HacktivityCon talk, or some of my stuff with HackerOne. Outside of work, I'm a Christian language enthusiast, handyman / real estate investor, and a rec volleyball player. So if we share any common interests, great, let's do that. So yeah, like Sam said, we're going to talk a little bit about a CVE that we found in an enterprise software, and just kind of the journey that entailed. So what would a good DEF CON talk be without some memes and some silly parts? So what I have portrayed for you right here is a day in the life of a bug bounty hunter, where you're in this desert and you feel like there are no vulns to be found. And in the distance, you see a mirage of RCE, of glory. But unfortunately, we are on the right side of this image, and the mirage of RCE is on the left. And there's a giant chasm in between us. KASM is the name of the software, so we had to do something funny with it. It's an enterprise sort of VDI software where users can spin up various containers and spin up various desktops and applications, and use those applications in a controlled environment. Yeah, Sam will talk a little bit more about that in just a second. So we threw a bunch of payloads at this thing after finding some sketchy stuff. Oh, actually, only one sketchy thing, and none of it worked. But eventually, after weeks and weeks of practice and perfecting the payload, we found the bridge, which is this monstrosity of a payload right here. And at the end of the day, we just slapped that fella down and walked across the chasm to RCE. So I'll hand it over to Sam now to tell you a little bit more exactly how we did that.
As I mute myself, thanks. So before we dive into the exploit, we have to talk a little bit about KASM Workspaces. So I guess next slide. Thanks. So KASM Workspaces is streaming containerized apps and desktops to end users. So what it really is it's you deploy Docker instances which contain desktops like Ubuntu or Chromium, and the KASM Workspaces will handle all the auth. It will handle the VNC connection to that workspace, and then you can do enterprisey things with it, like monitor the traffic or control access in enterprisey ways. And really, the target is for enterprise consumers, and so that might be why you've never heard of it. It's also not particularly it's not on the same level as Oracle, but it does seem to be pretty popular with some rather large customers, including one that we were looking at in the bug bounty program. So thanks. Next slide. KASM Workspaces is Docker containers all the way down. It's turtles all the way down, and So I apologize for putting so much onto a single slide here. This is really, the objective here is really just to show that there's a lot of Docker containers running, and I'll go into more detail when I have a visualization on a later slide. But really the two most important ones are the first one where you have this KASM proxy Docker container listening, and this is what's listening externally. You can see it's listening on the external interface, and then it's also it then is what handles all the traffic going through the system. And then the last row here is actually the desktop that I deployed. So next slide, I guess. Thanks. So in terms of what this routing actually looks like in KASM proxy, it's dynamically built Nginx configuration. And this is really important, but it's also kind of it's a little bit detailed here, and I apologize. But when you deploy a new container, this Nginx configuration will actually get dynamically updated, and a new containers.d file will be written, which contains some non-guessable paths. And this is what allows the VNC connection to be made from your browser all the way through to the container. Yeah, and so when there are new end user containers deployed, Nginx gets restarted with the new configuration. Next slide. Thanks. So this is a visualization of what that actually looks like. You're a happy user, you connect to Nginx proxy, and you connect to your containers. Next slide. Thanks. So Nginx KASM proxy routes all the traffic. The other important ones to call out here are the KASM API, which is what actually handles all the API calls that manage the system, and then KASM agent, which is what actually deploys the containers. KASM share and KASM manager are slightly less important, but they're still critical to the overall system. Next slide. And so when you deploy KASM Workspaces, you generally are deploying it to the enterprise. You're not deploying it to a single server. You want this to be able to handle, tens to hundreds to thousands of users. And so you're going to deploy it to a server pool. And so in order to accommodate that, it actually runs you can actually chain these KASM proxy processes together, and it will forward your request along. And so you'll have these kind of secondary servers where KASM agent is running that manages the deployment of containers on that local machine. And then, KASM API at the top level will manage all of that through the KASM proxy. Next slide. And so in terms of auth, this is just like a really simplified version, but it's good enough for this talk, I guess, of what the auth actually looks like here. Your end user credentials will get forwarded all the way through to your containers to interact with them. And then it will also end up in the KASM API. And then within the system, KASM API will use secret API keys that are only known to all of these processes to actually communicate with those processes. Next slide. And so, we were asked to look at this as part of a bug bounty program, and we couldn't find anything. And so we couldn't test this without source code. So we decided to see if we could test this with source code access. So before we go into that, we actually came across a public GitHub issues page where folks were reporting issues, and in particular, some of those were security issues. We didn't find anything here, but it's always worth checking before we continue along. And so we went to their website and go to kasmweb.com, and this is the most exciting thing to see as a bug bounty hunter. And I'll add some arrows to show why. So there's a couple here. Yep, thanks. And so this free button means you don't have to put in a credit card, you don't have to talk to a salesperson, you don't have to do anything, you can just download the software for free. And in particular, it says all features in enterprise, which is the most exciting thing to see. Next slide. And so at this point, we looked at the installation process and we saw it was downloading from Docker Hub. So we downloaded these Docker Hub containers and dove into them. And so at this point, we played a game that I like to call Find the API Endpoint, where we picked one of the API calls that has a somewhat unique string in it, like get user attributes, for example, here. And then we simply tried to find where that was running. And so in this case, I'm showing how we connected to the KASM API, Docker container, and then we grabbed that binary from it. back to our local system, pulled it back to our local system. So what's on the right here is how you're actually supposed to pull or extract the KASM, the Python code from the executable. In reality, it was far more based on strings and trying to figure out exactly how it was running. So if you ever need to do this, this is the quote unquote correct way to do this, where you can identify that it's Python, you can then use PyEnv and PyInstructor to extract it, and then actually decompile the compiled Python using uncompile 6. Next slide. And so, we eventually ended up at our function, and at this point, we have Cherry PY code, and we can finally now do the actual security work, quote unquote security work, looking through the source code. Next slide, thanks. So we came across this really interesting API call, or I should say Justin came across this really interesting API call. And this was actually, I believe, where he actually pinged me. It's like, hey, I found this thing. And the reason this is interesting is because it's actually taking user input and providing it as a parameter to this image host header parameter that then gets passed along as part of the Docker container generation. And so this request KASM API call is called when you are spinning up a new container. Next slide. And so it's actually, naively, we immediately plugged in a Burp Collaborator link, and we immediately got a call back. And so we were really, really jazzed at this point. So yeah, we thought we had a crit, and it turns out we didn't. We just had blind SSRF. It turns out we were getting our own cookies back, and there really wasn't anything particularly interesting that we could get as a request back using this, just passing a Burp Collaborator callback into as a host header. So we decided to see if we could take this further. And so it's hacking time.
All right, cool. I'll hop back in here. So now we had a sort of an interesting lead here. We were getting a callback from. Let me just hit this next one here. Yep, getting a callback from the Burp Collaborator, and as sort of Sam alluded to earlier, this is actually coming from dynamically generated Nginx configuration files. So that request, I'm just going to jump back a little bit here. That request KASM API call, which you see on the left-hand side there, and that Sam showed in this code right here, the cherrypy.request .headers host, it was taking the host header from that request, and it was using it to generate this Nginx configuration file when it spun up a new Docker instance, and that was allowing it to route to through the proxy configuration, as we showed earlier in the graphs. And so when we injected a different value in here, a Burp Collaborator instance, these internal requests, which were destined for the the newly spun up Docker container, were instead getting routed to our Burp Collaborator instance, which is what we were seeing the hits from. So this is cool, but like Sam mentioned, it's a blind SSRF. It's a medium at best. However, after a little bit more investigation, we did find that anyone who loads up the page where this instance where this instance that we created, this malicious instance that we created with that API request is displayed, the instance that we created, then their session cookies get passed through to us. So that's cool. We have an account takeover, but it requires user interaction and social engineering a little bit. And for any of you that have ever participated in Bug Bounty, they do play for some stuff like this, that requires user interaction and social engineering, but it greatly decreases your bounty. And as we showed in my beautiful graph in the beginning, we see the potential for RCE in the distance. So we want to try to go after that. So obviously, if we're injecting into a Nginx proxy pass, this is for those of you that aren't familiar with Nginx, this is a directive that allows you to pass a request, an HTTP request, to a different host. Obviously, when you're dealing with something like that, the first thing that comes to your mind is full read SSRF. It would be great if I could hit that path and then get the response. And if you can do a full read SSRF in a lot of modern day infrastructure, you're going to end up getting RCE due to the way that cloud stuff has been configured, and the ability to pull the cloud credentials associated with a certain instance and things of the like. So that's what we were going for. We're going for the full read SSRF. And so let's see what kind of roadblocks we ran into with that. So first, you'll notice in the definition, in the Nginx configuration file definition, the first location field, we thought, hey, let's see if we can hit that GUID. We found the GUID and everything, but unfortunately, it's got the internal directive. And the internal directive limits access to this endpoint only from internal requests, internal redirects, mod rewrite, that sort of thing. And so that is entirely inaccessible to us. So we started looking at the next one, and unfortunately, that GUID that is placed there is literally nowhere. We searched everywhere. We looked through the source code. We looked for any ways that we could leak this, and it won't leak. And you can see that there's a mod rewrite rule to prevent us from leaking that GUID to ourselves or something like that. So that's a real pain. That was a big sad, very big sad. So we couldn't really go full read SSRF. So we're thinking, okay, where do we want to pivot now? And then we started thinking, hey, there's some, Nginx variables in there, right? See remote address forwarded for. Maybe we can leak those via, like the blind SSRF that we've got. You can see the remote address right there. So we looked up, we said, hey, let's look up all of the, Nginx variables that there are. And lo and behold, there's an alphabetized index of those variables. And there's 220 of them that we could access on the Nginx documentation. And not a single one of them was juicy in any way, shape, or form. So that was not great. We were thinking perhaps we can, add at the end of our proxy pass / $ remote address or something like that and leak, juicy information, but there's literally nothing we could leak. So we got, that got us thinking about variables, and then we're thinking about, I wonder if we can leak environmental variables in any way. Is there a built-in Nginx directive or something of the like that would allow us to leak environmental variables? So we started looking at that, and of course, like any good hackers, we just threw it into Google and said, Nginx, how to access Nginx environmental variables. And this gem of a Stack Overflow article popped up saying, oh, the best way to get environmental variables is to run arbitrary Lua code or Perl code in your Nginx configuration file. And then we said, don't mind if we do run arbitrary Perl and Lua code in our Nginx configuration file. So we started barking up that tree to see if we could, get code injection. And unfortunately, nope, not gonna happen. And I don't know if we specified this before, but the kind of the point of this talk is to show you the ups and downs of bug bounty hunting, right? This is how many times we banged our head into a wall before we finally popped it. I mean, yeah, I don't want to spoil it, but yeah. So anyway, we barked up this tree and we tried to find what kind of modules were loaded in. Could we run Lua, Perl, and actually JavaScript is another thing you can run. But there were no modules loaded, and even though the Nginx command sort of teased us a little bit with this Perl modules path, that path did not exist, which is unfortunate. So no way to execute code. So now we're thinking okay, well, we can't execute code. We can't leak any environmental variables. We can do SRF. Maybe we could just do Nginx configuration injection and do something crazy and get DOS or, I don't know. We were just kind of playing around. So at this point, we started to try to inject in some additional, Nginx configurations. So, we took that host on the left-hand side there. We closed that portion of it off with a curly bracket. And then we tried to restart another location definition. But unfortunately, Nginx was not having that. The Nginx proxy that was sitting in front, remember, we're talking to an API through an Nginx proxy. And that we go through the Nginx and we go to the proxy, and then the proxy modifies the Nginx configuration file. So we're going through several layers of Nginx here. And the first layer, the outermost layer of Nginx, did not like anything weird in the headers. No spaces, no slashes or anything. All right, so just to summarize right here where we're at, we're going to go ahead and do a what's the sitch here. We have a Nginx config injection vulnerability that leads to blind SSRF. There is a way that we can leak the cookies of the victim who views our instance, but that takes a decent amount of user interaction and social engineering and decreases the impact of our vulnerability pretty substantially. We can't get SSRF because of an internal directive and a undiscoverable GUID. There's no interesting variables to leak, neither environmental variables or Nginx variables. We have no access to Perl, Lua, or JS or any other code execution methods. And we can't use spaces or slashes in our Nginx file configuration injection. Nginx configuration file injection. So this is looking pretty rough right now. You know, Sam and I have invested quite a bit of time into this already, and we're coming up short. Then Sam has a brilliant idea. He says, hey, I'm going to try calling the API directly from within a container and see if Python is okay with spaces in the host header rather than Nginx. So we should probably have injected, you know, a example of the that little graph that we had in the beginning when Sam was explaining the architecture. But the containers, right, are part of Docker as well. They're spun up in Docker, and they can access the other containers, or Sam was thinking maybe they can access the other containers, such as the API container, where
hit next slide here. It's on the next slide.
Does it?
Yeah.
Oh. That, exactly. Thank you, Sam. So there we go. So the end user containers, we're thinking, hey, maybe we can access the KASM API directly right through there, right? So that was a great idea by Sam. And so he went, boom, I'm just going to go ahead and spin up a Ubuntu instance here. And lo and behold, it worked. So Sam's idea came to fruition, and we were able to actually access the API directly, which solved our weird characters in the host header problem. So shout out to Sam for that awesome idea. So then we went down a whole path that we'll explain a little bit later. Got an exploit working. You know, we're ready to pop this thing, and boop boop, doesn't work because you notice the left-hand side has you know, the networking configuration for a single server setup, whereas our production instance actually has the multiple server setup on the right-hand side, where the end user containers cannot actually access the KASM Web API container. So now we are stuck again. So yeah, we're stuck. And we needed a way to smuggle the host header into the KASM API through Nginx. And we tried a bunch of stuff here. We spent a lot of time here. I don't know why we were so obsessed with this vulnerability, but we were, and we kept on kind of bumping off of each other and being like, yeah, you know, what if we tried this? What if we tried that? So some of the things we tried were we looked into HTTP request smuggling. We looked into the Nginx source code. You know, if you're looking at the Nginx source code, you're in deep. You're really in deep in a vulnerability. And we couldn't figure out a way around that. We looked for vulnerabilities in the Nginx header parsing logic. Couldn't find anything there. And then we repeated that process with Cherry PY. And you know, no Nginx vulnerabilities, no Cherry PY vulnerabilities. Then we stumbled upon this thing. Cherry PY supports ISO 8859-1 headers. Cherry PY supports ISO 8859-1 headers. And what the heck is that? If that looks in any way, shape, or form familiar to you, then it's probably because it's a part of the SMTP protocol. And we'll talk about that in just a second. But yeah, at this point, I hit up Sam and I was like, dude, I've got something crazy. And you can see right above, I'm like, oh, dude, man, this bug, it's going to be the end of us. And then, you know, 15 minutes later, I'm like, I've got it. Sam, call me ASAP. So anyway, this is what that kind of looks like. Like you said before, it's related to SMTP protocol. If you go to Gmail and you click like see original and stuff like that, a lot of the headers and the content body in some scenarios are going to be encoded using ISO 8859-1 protocol there. And actually, Cherry PY will, for some reason, take these headers that are defined in this format, and it will decode them and normalize them. So you can see up in the code snippet up at the top right, if the text starts with equals question mark, then it's going to go ahead and decode the value, which is great because none of the characters in ISO 8859-1 are invalid characters for Nginx. So you can kind of see where we're going there. And also the really nice thing about this is that it's really simple to do. You just take your text and essentially you URL encode it, which is a very common thing that we use in web vulnerabilities or web period. Is you URL encode it and convert it into its hex representation of that ASCII character. And then you simply replace the percentage signs, which are a part of URL encoding, with equal signs, and then you slap it, right in between, right here. I don't know if you can see my cursor. Yeah, you can. Into the hex, but it's a little off. Yeah, hex representation of the characters right in there. And so you wrap it in this equals question mark and with the Q, and then you have this little ending piece here as well. And then you can send that along, and this is what, this shows the decoding process right here, and it's going to convert those hex representations into the actual characters, and this normalized value is what's going to be passed to, Python when it's processing the request. So that's the way that we found our way around smuggling these values through Nginx. And then I'll pass it back to Sam. He's going to talk a little bit more about the exploitation process.
Thanks. So at this point, we were really excited. It's like, yes, we finally have an exploit or a way through this really complicated system. However, we landed at the configuration file, and the configuration file that we were looking at, we were actually injecting into 6 different places. And at this point, like, it really was starting to feel like a CTF problem, where it was just like really overly complicated trying to find a solution here. And so, we were injecting into 6 places. 2 of them were these proxy pass directives where we weren't in quotes. And then the last 4 were these add header directives where we were wrapped within single quotes. So next slide. And so, we tried the obvious thing of adding a new location, and this didn't work because you can't have duplicate locations in Nginx configuration. And in retrospect, we could have come up with there was a solution that could have worked here, but at the time, this didn't work. And then down below this, the bottom 4 locations would be ignored because that would be wrapped. This whole thing would be wrapped in single quotes, so that would be safe. So next slide. And so we tried what I can only describe as like quote magic. I can't think of a better term, where we would use the quote precedence to try to inject only a single path. However, in between the top two places that we were injecting, there was a single $sign, which broke all of this because you can't have individual $signs in Nginx configuration as it's an invalid variable name. Next slide. There actually is a workaround for this where you can define geo default $sign. However, that wasn't allowed here because of where we were injecting into. It has to go at into a higher stanza than we had access to within the Nginx configuration. And we couldn't just close off the brackets either because this was being included as a file within the server stanza. Next slide. So congratulations, you've reached the most boring part of the presentation. I mainly just wanted to show this to show the pain, misery we went through trying to exploit this, but also that we were trying to work through how to do this within Nginx configuration, and we inadvertently became Nginx configuration experts in the process. Next slide. So this is where things started to work. So this was, so it turns out you can actually repeat regex locations, and as I sent over to Justin, your sauna back, that's big. And so the reason that this works is that with Nginx, when it parses a configuration, it actually parses out all the static paths first, and when there are duplicate, and then it will try and match against. It'll like build a table, and it'll try to match against them and direct your traffic very quickly. With regular expression, it actually doesn't build that table. It just keeps them in a list, and it'll walk through that list. When it comes across the first match, it will forward it along, and that allows us to inject two identical regex locations into this, which allows us to get past this two injection point issue. Next slide. And so now that we could write arbitrary new locations to our Nginx configuration, we went about building gadgets. And so the first one we did, we finally built that full read SSRF. We built an LFI and directory listing so we could grab files back from the OS. Turns out there actually really wasn't too many interesting things here, simply because this Docker container was really locked down. There really wasn't anything in there besides the Nginx configuration. Yeah, there were some secret paths we could potentially get to, which were useful, but there weren't like secrets stored in there, for example. Also, the operating system itself was largely read-only, so there were no interesting places that we could write to as the Nginx process. Or not write, it wasn't write-only, it was just a restricted operating system where the Nginx just didn't have permission to do that. We also built a cross-site scripting payload just for fun. So we were kind of stuck here again. We were going through all of the available tags. It kind of felt like we were not going to be able to find our way out of this and just have to report this as a SSRF LFI, which is still good. It's still not RCE though. And so we kept going. So next slide. So there was one more tag, which is a little bit obscure, but actually ended up being really critical for our exploit to work. Client body and file only. And what this will do is when you send a post body, for example, through Nginx, it will actually write the body of that post request to a file, and it won't delete it once it's been written to a file. And really, this isn't a security feature. This is more of a sidecar process feature where it expects some Python, Perl, Lua sidecar process to pick up that file and do something with it after it received the request from Nginx. It's a little bit obscure, but it's going to be really important in a minute, and I'll show why in a second. Why? So if you remember this, and so you can see the red lines in particular going through the system, there are actually secret keys kind of flowing everywhere through this whole system, including through Nginx proxy. When you have a multi-machine setup, the secret keys that are used to communicate with KASM agent, which allows you to deploy new containers, will actually flow through the KASM proxy. And it just so happens that this is actually a post request with the key in the body of the request. And so, next slide. I asked, like, what if we can get those secret keys? Like, what if we can somehow steal that post request and intercept that secret key? So next slide. So we did it, but ignore everything on the right for a second, because we'll cover that in the next slide. So the concept here, we're going to carefully craft a single, we're going to carefully intercept one of the KASM agent requests using the client body and file only and write it to disk. And then we're going to use our LFI gadget to actually read that secret that just got written to disk. And so we got a little bit lucky here in that the secret was actually being passed through as part of the payload. But there was a bunch of stuff that went wrong, so it's kind of a balance. Oh, so one other thing to call out, and I don't believe we called this out previously, is that when an invalid configuration was actually, when you pass something that was an invalid Nginx configuration, the whole system would actually reject that container it would stop the container from being created, and it would actually reject that configuration change. So if we wrote an invalid configuration here, it would be rejected. And so it was really important that we kind of kept the whole system working correctly. Next slide. And so this is just a better visualization of what our final payload actually ended up being. So the first part of this payload is kind of an implementation detail where we have to keep that in place to keep the sort of more complex auth flow working, which we simplified in previous slides. And the blue stanza here solves the last 4 access control header injection points with a comment. So it essentially just closes off the rest of it. Works here both as a valid, it works in the top 2 as a valid set command. Injection points is a valid set command. And in the bottom 4, it closes off the single quote, and then the rest of this just becomes a comment. Then in white here, this is what's actually intercepting the call to agent API v1 hello. And I apologize for the fact that it's kind of shortened here. We had a 255 character limit from where we were passing it in through. So we had to shorten this to fit in there. So that's why it's a little bit code golfed, and I only needed the characters HEL. I didn't need to spell it hello, for example. Then we're going to use client body and file only, which will write the post body to disk. And then proxy pass will actually pass it along to the right place. We need to keep KASM agent working correctly, because if the system detects that KASM agent is down, then it will take that machine out of service, and we won't get the secret key, obviously. And then because this is like a hello, this is like a health check message that's coming through regularly that we're able to intercept here. And then the green location tag here, this is our regex secret backdoor LFI that will actually allow us to grab what gets written to disk. And then we close everything off cleanly with valid nginx syntax with an unused location regex. And this just keeps everything working correctly. It turns out that the container we actually deploy doesn't work, but the nginx configuration that gets written here allows us to intercept what we need. So it doesn't really matter if the container works or not. So next slide. So we sent it through, and this is actually pictures from our demo site that we had put some up ourselves. With it writing to disk, the file contents are that host token, and that is a randomly generated value for that KASM agent instance. We then use our LFI exploit to visit that path and grab one of those tokens. Next slide.
Yeah, I'll just point out really quickly right here as well. You can see in the path that test.secret, right? The VNC test.secret, which is utilizing that location in the green up here in the final payload. So, going to the next slide.
Yep. Yeah, so that those regexes ended up working out really well in the end. So now that we have this host token, we can now, the KASM agent API is actually really well documented on their website for third parties to develop against. And so we could just go and look at the documentation and figure out how this works. And what it does is it's a privileged Docker container, and in Docker parlance, privileged means that it has access to some special access to the underlying operating system. In this case, it had pretty much root access to the underlying operating system. And so what we actually did was we used the KASM agent API to make it has this concept of like an execution API call, where you can have it execute a command locally on on a Docker container that's running on the system. And in this case, we wanted to run it on itself. We obviously don't know the Docker container ID. Luckily, we can iterate through container IDs only when you're using the Docker API. You don't need the full container ID. You can pass it just a single character, and assuming that there aren't conflicts, it will get routed correctly. So you don't actually need the full ID. You'll see that often with when you're working with the CLI, you'll get a shortened version of the container is all you need to actually make your command work. And so that was the same was true here. And so in this case, I just had to iterate through the container ID to find the KASM agent itself. And once I found it, I then ran the privileged a privileged command, which was docker run in this case, which mounted the underlying host operating system into a into this it mounted the underlying host operating system into a Docker container that I controlled, and then I ran a command in there. In this case, I just touched a temporary file, and yeah, at this point we were asked to stop. We achieved a root write to the underlying operating system. We couldn't go any further. Next slide. Yeah, so we were unfortunately asked to stop here. The message that we got, so we were in communication with the bug bounty program at this point, asking if we was okay if we did this, because we were, modifying the underlying host operating system and spinning up Docker containers. We obviously wanted to let them know what we were doing. And the message we got back was, well, that's worrying. And at the end of the day, we got our RC, we got our crit. So next slide. So, these are the best slides in my opinion in any DEF CON talk. The vendor response, we contacted Nginx. They didn't consider this to be an Nginx issue, which is reasonable. This was really just a pass through, but they might consider introducing additional checks in the future. Cherry PY actually did address this for the host header. We actually never got a CVE issued for any of this. That's actually something that we should probably do.
Should look into that, yeah.
Yeah. If not for Cherry PY, then for KASM itself. And then KASM Workspaces did fix this in 1.11. So if you're a KASM user, make sure you upgrade. So next slide.
I'll hop in real quickly here and remind you, Sam, of a story you told. So like he said, in this little piece, you have to guess the container ID. And so when Sam was demoing this for, and the possibilities are A through Z, 0 through 9, right? So when Sam was demoing this for the team, he got all the way through A to Z and through 0 to 7, wasn't it, Sam?
Yeah, it was 7, I believe, was the magic number. They gave us like a few hour window to do this, and I was like so worried that it wasn't going to work.
Yeah, and he was like on the last 2 digits of that the container ID could possibly start with, and then it finally clicked. So that was a nail biter for sure.
Yeah, because it's like I didn't automate that at all, thinking, oh yeah, I'll get that quickly. How many curl commands could it take? Yeah.
Oh my gosh. So yeah, sorry. All right, hit us with the takeaways.
Oh, it's all good. So on the blue team side, how is your organization handling running multiple domain names? We see this all the time when we're looking at bug bounty sites. There's dev, test, QA, staging, pre-prod, prod domains. How does your code trust the host header coming in? Is it relying on user input? Because if it is, what does that then translate downstream? And that also comes up as well a lot with sending out emails, what are the URLs that the links contain, for example. Then on the Docker networking side, this is true with any networking really, but with Docker, you do have to be careful that you don't mix low and high privileged environments. And if you do, you just have to be very, very careful about it, obviously. And then on the red team side, we see you spraying payloads everywhere. So just add ISO 859-1 headers as well to that mix. Similarly, like what we did here, we tried to build gadgets where we could and document what we could, but really what we did bounced all over the place. And this presentation was far more logical than our workflow actually was. And similarly, collaborate. If we weren't working on this together, both of us wanted to stop independently at different times. So I think that worked out really well.
Yeah.
So yeah, questions.
And before we jump into questions, I will add something really quickly, because I've been talking a lot lately about bug bounty and getting people that are new to bug bounty, or that are in security already or not in security at all, getting into bug bounty. You hear this talk and you're like, wow, that's a crazy, this is probably one of the most crazy bugs, I've ever found. But getting into bug bounty doesn't always look like this. Sometimes it's you rotate an ID by 1 in a request, and now you've got a numeric IDOR that leaks the personal information of every user of the organization, right? And it's as simple as just looking at the HTTP requests and modifying one little digit. So I just want to give a little disclaimer at the end. Don't think that this is what bug bounty looks like. This is more, vuln research. And it's definitely, don't let this scare you from trying out bug bounty and giving it a go. So
yeah, just to add a little bit more to that. I mean, there's been plenty of bugs that I've found with you where it's just been, something silly or something trivial, and it'll never end up in a talk. It'll never even end up in a tweet for that matter, but it will probably pay more than this vulnerability did. And we spent a month working on this.
Absolutely. Yeah.
So this wasn't in terms of like time spent for payoff. In terms of dollar value, it totally wasn't worth it. It was worth it to give a talk on it though. That was the one place where it did pay off in the end.
It was. All right, cool. So with that, hit us with any questions. Ryan, do you, I know you've got some people there in person, and also anyone who's on the joining us online, feel free to just unmute and ask your question.
Yeah, thank you. Thank you both, Sam and Justin. I think we do have some questions. I'll go ahead there. It's through my laptop mic, so I'm going to step back and let him ask.
Okay.
So when you were working through the Nginx config file vulnerability, did you actually have a copy of the config files, or were you just going in blind and reading docs?
Yeah, we did. Thanks to that download button, with all the arrows from that slide, we were able to download the whole, software. And it was, because it's all Docker container based, it was surprisingly easy to set up. So we just spun it up and had our own local copy, and then we just hopped into those Docker containers and grabbed a shell in those Docker containers and started reading the Nginx files that we were injecting into.
All right, the whole talk I was wondering like how you were able to figure this out within your head, but it makes a lot more sense that you actually had hard copies of the config file. Thank you.
Dude, if we were going in blind, there would have been no way.
Yeah, absolutely no way.
Yeah.
Awesome. Well, I think anybody else have any questions? No? All right. Well, thank you guys for joining. I'm gonna stop the recording now. We don't have a YouTube channel at the moment, but we are gonna stand one up. So
awesome.
So I will get your final validation